Hi, welcome to ElimuHub. In this session, we're going to learn when to use the or and the and rules. Okay, so the first one we're going to start with is the or rule. What do we do when we have the probability of A or B? Well, we need to add probabilities. So when do we use this formula or this condition? Well, we need to have events that are mutually exclusive. That means events that cannot happen at the same time. I've got a coin here, so I could say what's the probability of getting head or tail? Well, we know that you cannot get both head and tail if you have just one coin. So their probability then, well, we know if you flip a coin, you can either get a head or tail. So the probability is going to be 1. So probability of getting head, we add probability of getting the tail, which is half plus half, which is going to be 1, of course. So I have a simple example here. What's the probability of picking a green or red counter from my pretty bag up here? So I have 12 counters in here, and I have 5 reds, I have 3 blue, and I have 4 green. Okay, so that's going to be 12 there. And we're asked to find a probability of getting green or red counter. So you need to bear in mind that I just want to get one counter and I only have one selection. So I'm not repeating, like taking another counter. So I only have just one selection. So probability of getting a green or red is going to be equal to probability of getting green plus probability of getting the red counter. Because if I just have one choice, I can only get one of these. I can get either a blue, green, or red. I can't have both because I am only choosing one counter. So probability of getting a green is 4 out of 12. And probability of getting the red is 5 out of 12. And then my answer, you add the 2, so it's 9 out of 12. And that can be simplified to 3 out of 4. So probability of getting green or red is going to be 3/4. Now we have the AND rule, and we are told now if we want two things to happen, like we get two events at the same time, we have to multiply their probabilities. So when do we use this formula? Well, we use this formula when we have independent events. And that means the probability of one event does not affect the probability of the other event. They are totally independent. So I have one simple example here. I have a coin and a die. So if I say to you, what's the probability of getting a tail and a number 6 and a 6 on a die? Okay, so we can get them because these are two different things. Whatever I get when I flip the coin is totally independent to the die. So in this case, I multiply their probability. So probability of getting tail times probability of getting a number 6. So it's a half for tail times 1/6 for getting a number 6. So that gives you 1 out of 12. So probability of getting a tail and a number 6 is going to be 1 out of 12. Right, now we have this example here, which also is an or situation. Probability of getting an A or B is equal to probability of A plus probability of B, but this time we're going to take away probability of A and B. So we've learned that if you have an or situation, you add their probabilities. Now the confusion is now, why do we need to subtract? Well, we did say the first one is an event that cannot happen at the same time. It's a mutually exclusive event. So this time, let's have a look at this example. It says, work out the probability of getting a number 6 or a diamond from a deck of cards. So let's have a look at this. Number 6. Well, how many number 6 in a deck of cards? There is 4 cards. And how many diamonds are there in a deck of cards? Well, there's 13. So this means we've counted this number 6. It's in here, but it's also in there. So this card is in both sets, and that is why we need to subtract the probability of A and B, because we cannot count it twice. Let me just show you. So we've got number 6, and we've got here diamonds. So there is 4, and we've got here 13. Now if we want to show this, that there is an intersection, well, what card will go in the middle? Well, it's a set, is a 6 of diamond. There's only one of them. Okay, so that goes up there. And how many number 6 are left? Well, there's 4 altogether. There's 1 there, so that means there's 3 here. And how many of diamonds are altogether? 13. So that means we can have 12. And that is the reason we do this kind of example. This is a visual understanding that if you have it counted twice, that's why you need to subtract here. So probability of getting a number 6 or diamond is going to be equal to probability of getting a number 6 plus probability of getting a diamond, take away probability of 6 and diamond. Okay, right, then probability of getting a 6 or a diamond is going to be equal to probability of getting a number 6, which is going to be 4. How many cards are there altogether in a deck of cards? Well, there are 52, so 4 out of 52 plus probability of getting a diamond card. Well, that's going to be 13 out of 52, and we have to take away a probability of getting a 6 and a diamond. So that's only one card that is both 6 and a diamond. So 1 out of 52. If you take this out, so that will give you 4 plus 13 is 17. Take away 1 is 16 out of 52. Simplifying that will give you 4 out of 13. Okay, so that is that situation. Here is a quick quiz, so feel free to pause and have a go and check the answers. You're asked to, it says add or multiply probability quiz. Getting a 6 on a die and a T on a coin. So, and what do? We multiply. Right, hitting a bullseye or a triple 20. So there's an or there. What do? We add probabilities. Getting a head, head, tail or a tail, head, tail after 3 throws of an unfair coin. Right, so there's an or there. What do we do when we have or? We add probabilities. Getting 3 on the first throw of a die and a 4 on the second. So what do we have? An and? We multiply. Ash's shoes could be 38 and Delilah's shoes size could be 40. So, and what do? We multiply. And Ali's eyes could be brown or black. There's an or, so what do? We add. Right. Here's a good question. It says Atif and Yasmin both come into school by bus from Kiswandui. The probability that Atif is late to school is 0.7. The probability that Yasmin is late to school is 0.4. Now, Masen claims that the probability Atif is late to school and Yasmin is late to school is 0.7 times 0.4, which is equal to 0.28. No, now we are told Masen is wrong. Why do you think this is the case? Because we are told if you're going to use probability that Atif is late to school, and you need to multiply the probability, but we're told Masen is wrong. Now feel free to pause the video and think and come back. Okay? Well, we use this and when we have independent events. So, I mean, it would be independent if Yasmin and Atif always take a different bus. But it could, in this case, it doesn't say so. So that means Atif and Yasmin could be on the same bus. In this case, this event is not independent, and therefore we cannot use this formula. We cannot multiply them. Right, thanks for watching. Please subscribe and like this video if it has helped you.